In this video, we will see how to actually carry out hypothesis test. We'll first consider the case of hypothesis test about a population mean, and then we will look at how to conduct hypothesis test about the population proportion. So for the population mean, our objective is that we have access to the sample, we do not know what the population mean is, and we are asking questions of the population mean based on our sample that we get. So from our sample, we will estimate the sample statistic or sample mean, X bar, and we will use this to conduct a hypothesis test about the population mean. So the first case we'll look at is if we know the population standard deviation sigma. In this case, the standard error or standard deviation of the sample mean is given by sigma over root n. And we will then construct a test statistic, which is essentially given by our sample mean minus our postulated or hypothesized value of the population parameter or population mean divided by the standard error of our sample mean. So this will give us a z-stat, and then whether we follow the critical value approach or the p-value approach, we can use this to draw conclusions about our test. What if we do not know the population standard deviation? In that case, we can proxy approximate it using the sample standard deviation, or S. In that case, the standard error of our sample mean is simply S over the square root of the sample size. Now, when we are approximating our population standard deviation with the sample standard deviation, instead of using the z-stat, we will use a t-test. So this expression, our sample mean minus our hypothesized population mean divided by the standard error of sample mean, will follow a t-distribution with the degrees of freedom equal to our sample size minus 1. And we can now compare this t-stat to our t-distribution table with the corresponding degree of freedom, and then make conclusions on our hypothesis test. Let's work with an example. Suppose a tire company advertises that its special tire, deluxe tire, averages at least 50,000 miles before they need to be replaced. So this would be the claim to be the population mean. And past surveys have also shown that the standard deviation of the population is 8,000 miles. We want to verify this claim. A survey is conducted of owners of this tire. The sample size of the survey is 32, so that's our n. And from the sample, we find that the sample mean mileage, or the average sample mileage, is 46,500 miles. And also the sample standard deviation is 9,800 miles. We want to conduct a test at the level of significance equal to 0.05, or at the 5% level of significance, to see if our claim is valid, that these tires last at least 50,000 miles before they can be replaced or not. So here, even though we are given the sample standard deviation of 9,800, we won't really use it because we're also given the population standard deviation. So if you're given the population standard deviation, we would always use that. So let us formulate our hypothesis. Here we are verifying, we are giving the company the benefit of doubt. So the company's claim will become our null. Our null will be that the population mean, or the mileage of these tires, is at least 50,000 miles. And then the alternative becomes the opposite, that it is less than 50,000 miles. So right off the gate, because it's a left tail test, because of the direction that the arrow in the alternative is pointing, it's a one tail, it's a left tail test. So the next step is to construct the test statistic. So here, some of the information that's given to us is that our X bar, or sample mean, is 46,500. Our population standard deviation is 8,000, and our sample size is 32 customers that we have surveyed. So we can first calculate the standard error of the sample mean. which is given by the population standard deviation divided by the square root of the sample size, which is 8,000 divided by square root of 32, and this equals 1414.21. So this is our standard error. Next, we will construct our test statistic. Again, because we know the population standard deviation, we will conduct a z-test. So our test statistic is our sample mean minus our postulated population value divided by the standard error of the sample mean. So we can now put in our values in there. We have 46,500 minus 50,000, which is our population mean, divided by our standard error, 0.21, and this equals minus 2.47. So now this is our test statistic, and we will compare this to the z distribution and see how likely it is to get a value as extreme as this. So for that, there are multiple ways we can do. We can follow the p-value approach. So we look up the probability of a value z being minus 2.47. So we choose a normal distribution and jump. It is standard normal. And we will input the values and calculate probability. So the first option, it's a left tail test. So we'll select this. And the value we'll input is minus 2.47. And we get a p-value of 0.0068. So our p-value is 0.0068, which is much less than 0.05 as our alpha or level of significance. So the way we would interpret this is that there's only a 0.0068 probability that our sample is coming from the population where our null is true. So because this chance is really small, it's below 0.05, there is sufficient evidence for us to reject the null. So in answering the question, is the data highly inconsistent with the claim? The answer is yes. The data is highly inconsistent with the claim that these stars will last at least 50,000 miles. So this is how we conduct a hypothesis test when we know the population standard deviation. Next, look at the case of conducting a hypothesis test when we do not know the population standard deviation. So here, let's say that there's a study which has shown that the average American eats 9.5 pounds of chocolate annually. So this is our population mean. We are curious whether citizens in Hershey have a higher average chocolate consumption than the national average. So Hershey surveys a sample of 36 individuals from the province, and we find that the mean annual consumption of chocolate is 10.05. Now, on the face of it, 10.05 is greater than 9.5. Does that mean that, yes, citizens in Hershey's on an average consume more chocolate than the national average? And we cannot conclude that. We have to conduct a hypothesis test because just the presence of our x bar being greater than our mu naught or the population mean is not enough evidence because this is just one sample, and we know that the sample mean itself is a random variable. And also notice here, we do not know the population standard deviation. We are given the sample standard deviation. So again, we are verifying a claim. We are conducting a study of a subset of the population. And we're interested in finding out whether citizens in Hershey consume on an average more chocolate. So we will formulate our null that mu is more than our national average, 9.5, and our alternative is that mu is less than or equal to 9.5. Again, putting down the values, our X bar is 10.05. Our sample standard deviation is 1.5, and our sample size n is 36. So we'll first get the standard error of the sample mean. It is given by our standard deviation of the sample divided by root n, which is 1.5 divided by square root of 36. And this equals 0.25. Now let's develop our test statistic. Now notice that because we do not know the population standard deviation, we are using the sample standard deviation, our test statistic will follow a T distribution, given by the degrees of freedom equal to n minus 1. Our n is 36. So our degrees of freedom will be 35. So our T-stat is, again, our sample mean minus our postulated population value divided by our standard error of the sample mean, which in our case is S over root n. We can plug in these values. Our sample mean is 10.05. Our population mean is 9.5. And our standard error is given by 0.25. Once we complete this calculation, we will get our T-stat equals 2.20. And this will follow a T distribution with our degrees of freedom equal to 35. So now we can look at the T distribution corresponding to 35 degrees of freedom and see how likely are we able to get a value as extreme as 2.2. So instead of our normal, we will switch to our T distribution. Our degrees of freedom is 35. And I want to again input the values and calculate the probability. But now notice that we are doing a right-tailed test because the arrow points to the right. So this is a right-tailed test. And here I'll put in the corresponding values. Our statistic is 2.2. We will conduct the right-tailed test, and we'll write in 2.2. And our answer is 0.0173. Again, our p-value, which is 0.0173, is much less than 0.05, which was our level of significance. So again, the conclusion is that the likelihood or the probability that our sample is coming from a population where the null is true is only 0.0173. So we have ample evidence to reject the null. So our conclusion is that people living in Hershey's, indeed on an average, consume more chocolate than the national average.